Hey everyone, today we are going to solve the Daily LeetCode challenge of 5th January 2024, and the problem statement is longest increasing subsequence. So let's first understand the problem statement. So according to the problem, we have been given an integer array nums, and we have to find the longest increasing subsequence. Now what a subsequence is? So a subsequence is when we select elements of array by maintaining their relative order. So let's see. Is 0, 1 a subsequence? Yes, it is a subsequence because we have selected 0 and 1 from this array and we have maintained their order. Means in the given array, 0 is coming before 1, and in the subsequence which we have formed, in that also 0 is coming before 1. So it is a subsequence. Is 0, 7 a subsequence? Yes, it is a subsequence. Why? Because we have selected 0 and 7 and we have maintained their relative order. Now, is 2, 0 a subsequence? So the answer is no. 2, 0 is not a subsequence. The reason being we have selected 2 from the array. It's fine. We have selected 0 from the given array. It's also fine. But are their relative order maintained? That is, in the given array, 0 is coming before 2. Is it maintained in the subsequence? No. We have written 0 after 2. So it is not a subsequence, right? Now, what is an increasing subsequence? So an increasing subsequence means, say for example, if I have an element here as A and I have another element over here B. So B should be always greater than A. Mind it should not be equal. It should always be greater, like strictly increasing. It should be strictly increasing. And say, for example, if I have another element C over here, then C should be greater than B. So if we have something like this, then we can say that, yes, it is an increasing subsequence. So let's see, is 0, 1 an increasing subsequence? So yes, it is an increasing subsequence. Why? Because 1 is greater than 0. Similarly, is 0, 7 an increasing subsequence? Yes, because 7 is greater than 0. Now, moving ahead, is 7 to a subsequence of this? Yeah, 7 2 is a subsequence because we have selected 7 from the given array and 2 from the given array, and their relative position is also maintained. Now, this is a subsequence, but is this an increasing subsequence? So let's see. 7 is 7 lesser than 2, means is 2 greater than 7? So no, 2 is not greater than 7. Instead, 2 is lesser than 7. So is it an increasing subsequence? No, it's not an increasing subsequence, right? Now let's see, is 2, 3 an increasing subsequence? So yes, it is an increasing subsequence because 3 is greater than 2, right? Now, what we have to find is we have to find the longest increasing subsequence. Means we have to give the length of the longest increasing subsequence of the longest increasing subsequence. Okay. Now let's see what could be our longest increasing subsequence in this example. So we can select this 0, we can select this 1, we can select this 2, we can select this 3. Is this a subsequence of nums? The answer is yes. Why? Because we have maintained the relative order. Now, is this an increasing subsequence? Yes. Why? Because here we can see that 1 is greater than 0, 2 is greater than 1, and again 3 is greater than 2. Okay, so this is an increasing subsequence. Now, what is its length? Its length is 1, 2, 3, 4. So its length is 4. And this is the longest, this is the length of the longest increasing subsequence for this example. Now, the question is, how are we going to solve this problem? So I'll be explaining two approaches in this video to solve this problem. So let's first walk through the first approach. Now you can see that if this is our given array, then for each of the element of this array, we are having two options. And what are those two options? Either this 0 is going to contribute to our answer, which means either we are going to add this 0 to our subsequence or we are not going to add it to our subsequence. Similarly, either we are going to add this 1 to our subsequence or we are not going to add this 1 to our subsequence. And we are either going to add this 7 to our subsequence or we are not going to add this 7 to our subsequence. And similarly, we are having those two options for 2 and 3 as well. So it means if we are present at any index of our nums array, so say for example, if this is the current index, then at this index, we are having two options. What are those two options? Either it is going to contribute to our subsequence or it is not going to contribute to our subsequence, which means either we are going to take it or we are going to not take it, right? So in the case when we are going to take and not take, so whenever we have an options, the first thing which strikes our mind is to use recursion. Okay, so it's recursion. So yes, we are going to use recursion for solving this problem. So now the case is if we are going to take an element, say for example, if I have taken 0 in my subsequence, so what does it mean? It means that I have taken an element, so it is going to contribute to its length. So I will be like writing 1 plus, and we will be making a recursive call. Let's say the function name of the recursive function name is lis. As of now, let's take it for simplicity as lis. So I'm going to make the recursive call, and I'll be writing this parameter later. Now, if I'm not going to take it, then will it contribute to our answer? No, it won't contribute. So I'll say simply 0 plus, and I'll make a recursive call, and I'll write this parameter in a while. Okay. So let's say if I have this as a subsequence, okay, and if I want to add this 4 to my subsequence, so what do I need to do? I need to first check that whether this 4 is greater than this 3 or not, right? If this is greater than 3, then only we can add it. because we want an increasing subsequence. So if I want to add this 4, I need to make sure that it should be greater than 3. Similarly, if in future I'll have something like 7. So for adding 7, what I need to do is I need to check whether this 7 is greater than this 4 which was added previously or not. Right. So what can I derive from here? It is that we need to keep a track of the previous element which we have added, right? Then only we can add a new element. Like whenever a new element will come, say this is a new element and this is my previous element. So whenever a new element will come, we have to make a check with the previous element, that such that the new element should be greater than the previous element. In that case only we can add it. So we need to keep a track of the previous element. So what we'll say is, so if we have taken the current element, what we'll do, we'll move to the next element. So this will become current index plus 1. Okay, since we have, let's say we have taken this 0. So after taking this 0, we will move to 1. And say, for example, if we have taken this 1, so we'll move to 7. So if I'm at current index and if I have taken this, so I'll move to the next index. And this one is for previous index. Now what my previous index would be, this current element which I have added to my subsequence, it will become the previous element, right? It will become the previous element to any new element which will arrive in future. So my previous index will now become current index. Similarly, if I have not taken element, so say for example, if I have not taken this 0, so I'll simply move to the next element. And if I have not taken this one, I'll simply move to the next element. So it will be current index plus 1. And what would be the previous index in this case? So the previous index will remain as it is, which means it will be previous index only. Why it will remain as the previous index? Say for example, if I have a subsequence like 1, 2, 3, and if I get an element as 0, so I'll make a check that is this 0 greater than 3? So no, 0 is not greater than 3. So it means we are not going to take this 0 and we'll move forward to some another element. So in this case, like in the previous case, when I was comparing this 0, what was our previous element? It was nothing but 3. Now, if I'm not going to take the 0 and I'm going to move forward to another element, so in that case, is my previous going to change? No. Why? Because it will remain the previous element only, because we have not added any other element, right? So this is what we'll be doing. So what our base cases will be. Okay, so the first base case which we can see is that, say for example, I have either taken or not taken this 0, and like I'm iterating over this nums array and I have completely exhausted this nums array. Like I have reached to its index which is equal to its size. So our first case would be if my current index becomes equal to, say for example, if n is the size of my nums, right? If it becomes equal to n. So in that case, what we are going to return? So if I have exhausted the element, like if I have completely traversed over my entire nums array and I have no elements left, so what is the length which it is going to contribute to? It's going to contribute a 0 length, right? Since we don't have any more elements, so it won't contribute to the length of our subsequence. That's why we'll be simply returning a 0. So this will be our base case. Now let's quickly do a dry run on this given test case. So initially our current index will be 0 and our previous index will take it as -1. So this is my previous index and this is my current index. So at this point, we are having two options, either to take or not to take. So if I take the element of 0th index, if I'm going to take this element, then what will happen? Since I have taken this element, so it will contribute to the length of the subsequence. So we'll add this and since we have taken this, we'll move to the next index, which is nothing but 1. And what will be our previous index? Our previous index will get updated to this 0. Okay. Now again, at this point, we are having two options, take or not take. So we'll come here to the take part. Now we'll see, can we take the element of the 1th index? Now before adding it to our answer, what we need to check? We need to check that is my element. So is my nums of 1 greater than nums of 0? We need to check this. So is nums of 1 greater than nums of 0? So yeah, this condition is true. So we are going to take the element present at our 1th index. So it will contribute to the length. So we are going to add 1 and we'll move to the next index, which is nothing but 2. And our previous index will get updated to 1. Now again, we are having two options, take or not take. Now before taking, what we need to check? We need to check that is the nums of 2 greater than nums of 1. This is the previous, right? We need to check that is the element present in my current index, which is nums of 2. Is that greater than nums of 1? So in nums of 2, we are having 7. Is it greater than nums of 1? We are having 1. Is it greater than this? So it's true. So what we'll do is we will add this to our answer and we'll move to the next index, which is 3. So we have come to the next index and our previous will get updated to 2. Now again, here we are having two options, take or not take. Now before taking, we'll check is nums of 3 greater than nums of 2? So in nums of 3, we have 2. In nums of 3, we have 2. Now we'll check, is this greater than nums of 2, which is 7? So is 2 greater than 7? No, it's not greater than 7. So we won't take this element, right? Because 2 is not greater than 7. So we won't have a take condition over here. So we'll move to the not take condition. So in the not take condition, what was our not take condition? Since we are not taking this, so it is not going to contribute to our answer. So it would be simply plus 0. We'll move to the next element, which is 4. So we'll come here and our previous will remain as it is, which is nothing but 2. Now Again, at the fourth index, we are having two options, take or not take. So if we'll take the element present in the fourth index, so before that, we need to check that is my element present at the second index lesser than the element present in the fourth index? So what's my element present in the fourth index? It's nothing but 3. And what's the element present in the second index? It's 7. So is 3 greater than 7? So no, it's not greater than 7. So we won't have a take call here as well because 3 is not greater than 7. So again, we'll have a not take. Now what we'll do, we'll move to the next index, which is 5, and previous will remain as it is, that is 2. Now we'll see that our current index has become equal to n. What is n? N is the length of the nums array, and in this case, length of nums array is 5. So since we have completely exhausted the array, so is it going to contribute to our answer? The answer is no. So we'll simply return a 0. So from this recursive call, we'll get a 0. So 0 plus 0 will be nothing but 0. Now we'll find the max of its left call and right call, that is from the take and the not take. So here also from the take part, we are getting a 0. So max of 0 and 0 will be nothing but 0. So 1 plus 0 will get a 1. And now we have to explore this branch, which is the not take branch. Since I don't have any space here, so I'll be writing it here. Like say I'm at 2, 1. We have explored the take part. So we are now going to explore the not take part. So if I'm not going to take the element present at the second index, so I'll simply move to the third index and my previous will remain as it is. And since we have not taken it, it will add 0 to our answer. Like it's not going to contribute to our answer. Now at 3, 1, we are going to have two options, take, not take. Now before taking, we need to check that if my element present in the third index greater than the one in the than the one in the first index. So what's the element in my third index? The element present in my third index is 2. Now I need to check, is it greater than the element present in my first index? The element present in my first index is 1. So is 2 greater than 1? So it's true. So we are going to have a take call. And since we are going to take this element, so we'll add a 1 as it is going to contribute to my answer. We'll simply move forward to the next index, which is nothing but 4. And our previous will get updated to 3. Now at 4, 3, again, we are going to have two options, that is take, not take. If we are going to take this element, now before that, we have to make a check that what is the element present in my fourth index? It is 3. Here it is 3. And what is the element present at my third index? It's 2. So I'm going to check, is 3 greater than 2? Yeah, it's true. So we are going to take this in our answer. So we'll have 1 plus. Since we have taken this element, we'll move to the next index and our previous will get updated to 4. Now you can see this is 5, which has become equal to our length of the nums array. So are we going to have any more answer? Because we don't have any more elements left. So we'll simply return a 0. So this will give us 0. So 1 plus 0 would be 1. And from here also we'll have a right call. Let's explore its right call. So if we are not going to take the element present in my fourth index, we'll simply move to the fifth index and our previous element will remain as it is. Since here as well we have completely exhausted the array, we are going to return a 0. Now at this point we are going to find the max of the left call and the right call. So from the right call we are getting a 0 and from the left call we are getting a 1. So what will be the max of 1, 0? It would be nothing but 1. So 1 plus 1, 2. So from here we are returning a 2. Now again we have to explore the right call of 3, 1. And from here also we are going to get some answer. And then at this point again we are going to find the max of this 2 and the answer which we are getting from the right call. In the same way, you guys can draw the complete recursive tree and you will be able to find that we are getting an answer as 4. And the longest subsequence would be nothing but 0, 1, 2, 3, which is this one. This 0, 1, 2, and 3. So let's quickly code this problem. So we'll start on by creating a function that will be, let me first write down the function over here. The function will be returning us an int and it will be find length of LIS. Okay. And what are we going to have? We are going to have the current index as the parameter, the previous index, and we are going to pass the nums array. Right. Now, as mentioned, what will be the base case? Base case will be that the current index has become equal to the size of our nums array. In that case, what we are going to do? In that case, we are going to simply return a 0. Otherwise, what we are going to do? We are going to have a take condition and we are going to have a not take case. And finally, what we are going to do? We are going to return the max of this take and not take. So let's write this take and not take. Now the question is, when are we going to take an element? So if my previous index is equal to -1, what does it mean? That it means that we have not added any element till now. So we can simply add that element, right? Or what will be the other case? The other case would be my nums of current index if this is greater than the value present at my previous index, right? In that case, we are going to take. Let me initialize take as 0 over here. So in that case, we are going to take. So if we are going to take an element, it will contribute to our answer. We'll add a 1 and we are going to make this recursive call. Now, since we have taken this element, we'll move to the next element, which would be current index plus 1. And our previous element will get updated. Why? Because since we have taken the element of our current index, so what would be the element present at the last of our subsequence? It would be nothing but the element at current index, right? So we'll update our previous as well. Now, for the case when we are not going to take, so what we'll have is, let's say int not take. So if we are not going to take an element, it's not going to contribute to our answer. So we'll say 0 plus find length of LIS. And if we are not going to take this element, we will simply move to the next element, which will be current index plus 1. And since we didn't added this element, so the previous index will remain as it is, right? So it would be nothing but previous index. Sorry, I forgot to write this nums over here and here. Yeah. So now let's say that return find length of LIS. And what are we going to pass? Our current index would be 0. Previous, initially it would be -1, and we are going to pass the nums. So let's run this on our given test cases. Sorry, it would be previous index. So it's giving the correct answer for all the given test cases. Now, while doing this dry run, you'll see that you have got lots of overlapping subproblem, right? So whenever we get an overlapping subproblem, what we do is we introduce DP. We can either do memoization or we can do tabulation. As of now, we'll be doing memoization, and in the later part, we'll be doing the tabulation as well. So we'll be doing memoization. Now, for that, in the recursive call, let's see what are the things which are changing. So we can see that current index is changing as well as our previous index is changing. So we are going to have a 2D vector, right? Because we are having two of the parameters which are getting changed. So let's create it. Say this is vector of vector int. Let's name it as memo. Now what will be the length? Now my current index, what can be the maximum value that my current index can take? It would be nothing but the length of the nums array. Similarly, what could be the maximum value that my previous index could be taking? It would be the same as that for the current index. So let's say int n equals to nums dot size. Then let's say its size is n, comma vector int of size n, comma. Initially, let's take all the element as -1. We are going to pass this memo over here, and we are going to pass it here as well. Let's write as vector of vector int memo. Now, before making this take and not take call, what are we going to check is we are going to check if my memo of current index and my previous index is not equal to -1, then I'm going to return memo of current index, comma, previous index. Similarly, before returning, I'm going to store this value in my memo of current index, previous index, right? And what I can return from here, I can return simply memo of current index, previous index. Now, one thing you can note that what is our value of previous index? It's initially -1. So are we going to have a coordinate like 0, -1? Here we have written current index, which will be 0, and previous index as -1. So it's no, we'll be getting a runtime error. So what we'll do is like, say for example, if we have, if we have index as -1, for that we are going to store its value at -1 plus 1, which is at 0th index. And similarly, for the 0th index, where are we going to store its value? We'll be storing its value at 0 plus 1, which will be at 1th index. Similarly, for 1, we are going to store its value for 0 at 1 plus 1, which is at 2nd index. So it means that since we are having a negative value, right? So we can't have a negative index in our vector. So what we are doing is we are shifting this by 1. We are shifting this 1 position right. So how are we shifting it 1 position right? By adding 1 to it. So eventually this should be +1 since we are shifting 1 position right. So we'll need 1 extra space. And here we need to say that previous index +1, previous index +1. Similarly, here it would be previous index +1, and here it would be previous index +1. Now let's run this. So it's giving the correct answer. Let's submit it. So it got accepted. Now let's see what is the time complexity and the space complexity. So you can see that here at every element, for every element, we are having 2 options, right? It means for this 0, we are having 2 options. And similarly, for this 1, we are having 2 options. For this 7, we are having 2 options. So say, for example, if we have an array of n length, so at each position, we are having 2 options, right? So total, we are going to have a time complexity of 2 to the power n. This would be our time complexity. And what will be our space complexity? Here you can see that we have used a 2D vector, right? We have used a 2D vector for storing all the elements. So it is going to take us a space complexity of n cross n. Now moving ahead to the second approach. Now in the second approach, we are going to take an array whose size would be equal to the size of the nums array, and we'll name this as DP. Now what this DP is going to do is it is going to keep track of the length of largest increasing subsequence till that index. It means if I'm present at 0, so it means it is going to keep track of the length of the longest increasing subsequence till the 0th index, means till here. And if I'm present at 1, it means that it is going to keep track of the length of the longest increasing subsequence till the first index, means from here to here, what is the length of the longest increasing subsequence. Similarly, if I'm at 2, it is going to store that what is the length of the increasing subsequence till the second index, means from 0, 1 till 2. And similarly for 3 and 4 as well. So let's take another example. If we have an array like 5, 4, 3, 2, 1. So you can see that this is a decreasing array, right? Now, if I have a DP array, so what it is going to store in its 0th index? It is going to store 1 as the length of the largest increasing subsequence, because till here, what is the length? It is nothing but 1. Now, if I'll come to this point, what is the length of the largest increasing subsequence? It's 1. Why? Because since 4 is not greater than 5, so we'll have only 4 over here. Similarly, when we'll come to this point, what it is going to store? It is going to store 3 again. Why? Because 3 is not neither greater than 5 nor it is greater than 4. So we'll have only one element, which is 3, right? Now coming to here, what it is going to store? It is going to store 1. Why? Because 2 is neither greater than 4 nor is greater than, neither greater than 5 nor greater than 4 or 3. So we'll have 1 over here. Similarly, for 1, we are going to have 1. So from this, we can see that at the worst case, each of the elements of my DP array would be 1. And now what we are going to do is we are going to iterate from the first index till the last index. Now you may ask why I'm not going to consider the 0th index, because it is obvious that irrespective of whatever my array is, if I'm present at the 0th index, the largest possible length of my longest increasing subsequence will be always 1. I can't have any more than one element till this point, right? So it will always be 1. So you don't need to iterate over the 0th index. Now what we'll do is we'll start iterating from I equals to 1. Okay. Now my ith pointer is over here. And I'll run another for loop, say it's j, and it will start from the 0th index till the ith index. And what I'm going to check is, I'm going to check if my nums of j is lesser than my nums of I. It means that we have got an increasing subsequence. So what I'll do, I'll simply update the value of my dp of I as the max of dp of I, comma 1 plus dp of j. Right. So let's see. If the value of I, let's take initially the value of I as 1 and the value of j as 0. So I'm present at I equal to 1 and j is at 0. Now I'll check. Is 1 greater than 0? So yeah, it's true. 1 is greater than 0. So I'll update the value of 1 as max of 1, comma, what it will be? It would be dp of 1, comma, 1 plus dp of 0. So what is dp of 1? It's nothing but 1. And here it would be 1 plus what is dp of 0? It's nothing but 1. So what would be the max of 1 and 2? It would be nothing but 2. So we'll update the value of 1 as 2. And you can also see that if we are present at this index, if we are present at this 1th index, then what is the length of the largest increasing subsequence? It's 2, right? Because 1 is greater than 2. So we can have this as our increasing subsequence, right? Now we'll move to the another index. Now j will become equal to 1. So since j has become equal to I, so we'll end the loop for this one. Now my ith pointer will move forward. So my ith pointer is now present at the second index. So my I is equal to 2. So again, my j will become equal to 0. Now I'll check. Is 7 greater than 0? So yeah, 7 is greater than 0. So I'll update the value of this index to 2. Right? Now my j will become equal to 1. Now I'll check. Is 7 greater than 1? So yeah, 7 is greater than 1. Now what I'll do? I'll check this condition. What is my dp of I? My dp of I is currently 2. And what is 1 plus dp of j? 1 plus dp of j means 1 plus the value present at my 1th index. What is the value present in my 1th index? It's 2. So what will be the max? Max will be 3. So again, I'll update the value present in my second index to 3. Let me rewrite this. This will get updated to 3. Additionally, you can see that what is the length of the longest increasing subsequence till this point? It's 3, right? We can have 0, 1, 7, something like this. So what's this? This is nothing but 3. Now my jth pointer will increment. It will become equal to 2. So we'll end for this. Now my ith pointer will move to the third index. So I'm here. Now what is the value at my third index? It's 2. Now my jth pointer will become equal to 0. Now I'll check. Is 0 lesser than 2? So yeah, 0 is lesser than 2. So we'll first check that what is dp of 0 plus 1 and what is dp of 3. So dp of 3 is 1 and what is dp of 0 plus 1 is 1 plus 1. So what is the max of these two? The max of these two is nothing but 2. So we'll update the value to 2. Now my jth pointer will become equal to 1. Now I'll check. Is the element present at the 1th index? What is the element present at 1th index? It's 1. Is this lesser than 2? Yeah, it is lesser than 2. So again, we'll make a check of this. What is the max of dp of 3, comma, dp of j? What is j? J is 1. dp of j plus 1. So what is dp of 3? dp of 3 is 2. What is dp of 1? dp of 1 is 2. 2 plus 1 is 1. So what are the max of these two? The max is 2 plus 1, 3. So we'll update this value to 3. Now my j will become equal to 2. Now we'll check the value present at second index, is that lesser than the value present in my third index? So it's not lesser than that, right? 2 is not greater than 7. So we'll move to the another index, which is 3. Now these have become equal, so we are done for this call as well. Now we can also see that if my pointer is at third index, so what is the maximum length which we are getting? It's nothing but 3, which would be 0, 1, 2, right? Or it could be 0, 1, 7, right? So if we are present at the third index, so till third index, there is no way that we are going to get a length greater than 3. Okay. Now my ith pointer will move forward to 4. Now my I is equal to 4 and j will become equal to 0. Now we'll check what is the value present at my fourth index is 3. Is 3 greater than 0? Yeah, is greater than 0. So now we'll check what is the max of dp of 3, comma dp of 0 plus 1. So dp of 3 is, it would be dp of 4. So what is dp of 4? dp of 4 is 1. What is dp of 0? It's 1. So 1 plus 1 is 2. So what are the max of these two? The max of these two will be 2. So we'll update it to 2. Now j will increment to 1. Now what is the value present at my 1th index? It's 1. Now we'll check. Is 3 greater than 1? Yeah, it's true. Now we'll again check. What is the max of dp of 4, comma dp of 1 plus 1? So what is dp of 4? dp of 4 is now 2. And what is dp of 1? dp of 1 is 2. So we'll have 2 plus 1. What are their max? Their max is 3. So we'll update this 2 to 3. Now my jth pointer will become equal to 2. Now we'll check what is the value present at my second index. It's 7. Is 7 lesser than 3? No, it's not lesser than 3. So we will not make any comparison or updation and we will simply move our jth pointer to the third index. Now we are at the third index. What is the element present at my third index? It's 2. Now we'll check. Is 2 lesser than 3? So yeah, 2 is lesser than 3. So again we'll check what is the max of dp of 4, comma dp of 2 plus 1. So dp of 4, what is dp of 4? dp of 4 is 3. And what is dp of 2? dp of 2 is again 3 plus 1. So what are their max? Their max is 3 plus 1, which is nothing but 4. So we'll update this 3 to 4, right? And we'll increment our jth pointer. It will become equal to 4. We have now completed for this as well. Now we'll increment our pointer. Now my ith pointer will become equal to 5. Since we don't have any fifth index, means we have completely exhausted. And what would be our answer? Our answer would be the max of 1, 2, 3, 3, and 4. So what are their max? Their max is nothing but 4. So 4 is our answer. And you can also see that what would be the subsequence? We can draw it over here. So our subsequence would be either 0, 1, 2, 3. So this is our answer. And this is having a length of 1, 2, 3, 4. Right? Now let's quickly code this one. So initially we are going to create a vector called dp whose length would be nums.size, and initially all the values are 1. Now what did I say? That we are going to iterate. Let's see, this is current index. It's going to start from 1 and it would be lesser than the nums.size, and we have to increment this, right? And next what we are going to do, we are going to run a jth loop. From where the jth loop is going to start? The jth loop is going to start from the 0th index till it's not equal to the ith index. So I'm going to say that for int, my previous index will start from 0 till my previous index is lesser than my current index, and we are going to increment my previous index. Now what we are going to check? We are going to check if the value present at my previous index is lesser than the value present at my current index. It means we have got an increasing subsequence. So what we are going to do? We are going to say that my dp of current index would be nothing but maximum of the value present at my current index and the value present at my previous index plus 1, right? And what we have to do is we have to find the track of the length. So we can say that max length variable, initially it would be 1. Why I have taken this as 1? The reason is, say for example, even if we have an array like this, so what is the length of the maximum increasing subsequence? It's nothing but 1, right? So even in the worst case, like if we have an element, like if we have only one element, its length, max length would be 1. So let's take this value as 1. And what we are going to do is we are going to set our max length as the max of max length and the and the dp of current index. And finally, we are simply going to return the max length. So let's run this. So we are getting an error and it says that, okay, so it would be here plus. Now what is the error? It would be current index. It got accepted. Let's submit. It got accepted. Talking about the time complexity and the space complexity. So the time complexity would be order of n square. Why? Because we are iterating first through all the elements of the nums, and inside that we are having another for loop. So this is going to take an order of n, and this is also going to take order of n. So it would be order of n square. And what is the space complexity? It's going to be order of n because we are having a dp array which is having a size equal to the size of the nums array, right? So this is all about today's daily LeetCode challenge. Thank you.